Welcome back, everyone, to today's Explainer. I am so excited you're here because we're looking at one of the absolute most mind-blowing thought experiments in all of astronomy. We're going to explore a scenario that sounds like pure science fiction, for sure, but it forces us to confront some very real, extremely fascinating scientific concepts. We are talking about Earth adrift, a complete, literal galactic relocation. Just try to imagine the sheer scale of taking an entire planet, our home, and dropping it into an entirely different corner of the universe. It's a massive concept, so let's break the whole shebang down.
Now, I want you to picture this for a second. You go to sleep on a totally normal Tuesday. You wake up the next morning, step outside with your coffee, and you wait for the sun to rise. But when you look up at the pre-dawn sky, nothing is where it should be. The constellations you've known your entire life, the Big Dipper, Orion, that faint cloudy band of the Milky Way, they're entirely gone. Just poof, replaced by a completely foreign canopy of stars. What if you woke up to discover that our entire planet had somehow been moved completely out of the Milky Way and into a totally different galaxy?
Okay, let's dive into this. Section 1, waking up somewhere else. So, the absolute first indicator that something has gone impossibly wrong, or maybe impossibly right, depending on how you look at it, is that the familiar night sky simply vanishes. For the average person, it would just be super confusing. But for scientists and astronomers at observatories around the globe, well, it would be an absolute panic. They'd point their telescopes at the heavens and realize that the cosmic map they've studied for centuries has literally been wiped clean. Within hours, this terrifying yet awe-inspiring consensus would start to form. Our familiar stars have disappeared, and Earth is no longer in the Milky Way. Now, to truly understand the gravity of this displacement, we really have to grasp the sheer, terrifying scale of the intergalactic void. Because our planet doesn't just float in some uniform expanse. It's bound gravitationally to a local cosmic structure. When we talk about moving galaxies, we aren't just crossing a little bit of empty space. We're crossing expanses of nothingness so vast that they completely dwarf human comprehension. Like, for context, the distance to our nearest major neighbor, the Andromeda Galaxy, is 2.5 million light-years. That means traversing a void where virtually nothing exists for 15 quintillion miles. To put that in perspective, that's a 15 with 18 zeros behind it. It's just wild.
And the cosmic neighborhood we literally just left behind? The Milky Way. The magnitude of this loss is genuinely staggering. The Milky Way was our cosmic home, a sprawling, beautiful spiral galaxy containing billions of stars, countless nebulas, and this intricate gravitational dance that we've spent all of human history trying to understand. To be plucked right out of it means losing our entire astronomical context. Every single map we've ever drawn of the universe was drawn from one specific vantage point inside the Milky Way. And now, that vantage point is gone.
All right, Section 2, the mechanics of the move.
Now, what's really interesting about this side is, how could Earth actually be moved? Because modern physics basically tells us this kind of instantaneous travel is impossible, we'd have to look to the absolute outer edges of theory. Are we some kind of massive science experiment plucked by a highly advanced Type 3 civilization? Or was it an entirely unknown cosmic event like a spontaneous tear in spacetime? Or maybe a massive wormhole that just swallowed us whole? We'd be operating entirely outside the boundaries of known science here, completely in the dark. And the immediate physical consequences, those are literally what dictate our survival. First off, did our sun, moon, and neighboring planets come with us? I mean, if just the Earth was teleported, we'd freeze in the dark void of space within days. So we kind of have to assume our entire local solar system was moved together. Next, we have to consider Earth's position in this new galaxy. Are we near a volatile galactic center or safely tucked away in the outer spiral arms? And absolutely crucial here, how does the overarching gravitational pull of this new galaxy alter the delicate orbits of our solar system? Even the slightest gravitational nudge could change our climate drastically.
Which brings us to Section 3, the human impact.
The initial phase of this whole event would be just pure, unadulterated global shock. Institutions would scramble, and societies everywhere would grapple with the immense existential dread of being utterly lost in the universe. But hey, humanity is remarkably resilient. That initial shock would inevitably transform into this insatiable curiosity. This displacement would spark a grand awakening. We'd basically enter a golden age of unified global research, driving scientific discoveries at a completely unprecedented rate, and forcing us to ask some massive new questions about our purpose and our future.
Let's move to and see how this builds. Section 4, exploring our new home.
The thrill of discovery in this scenario is genuinely staggering. We'd be pointing our instruments at strange, totally new stars and planets. Just imagine seeing twin suns in the night sky or colossal nebulas glowing with energetic signatures we've never ever observed locally. We'd witness never-before-seen cosmic phenomena, perhaps exotic types of star formations or completely different physics at play in local star clusters. And, okay, the most tantalizing prospect of all, the possibility of alien civilizations. A new galaxy means we're essentially rolling the dice all over again on the Drake equation. We might suddenly find ourselves in a neighborhood teeming with advanced life.
Section 5. Advantages and Hidden Dangers.
And this brilliantly illustrates the ultimate trade-off here. We have to weigh an astronomer's absolute wildest dream against some terrifying, unknown cosmic threats. Yes, we gain a massive leap in our understanding of the universe, with fresh planetary bodies to study and the incredibly exciting prospect of meeting new civilizations. But on the flip side, we're facing completely unknown dangers. We don't know the ambient radiation levels of this new galaxy, or the frequency of supernovas, or the prevalence of wandering black holes. There could be subtle, creeping changes to Earth's environment. And above all that, we'd really have to process the profound psychological and physical reality of total isolation, entirely cut off from our origins.
And that leads us to Section 6, the future of human science.
Let's be real, the challenges of traveling between galaxies are immense. In fact, with our current understanding of physics, it's pretty much impossible. I mean, we can barely send probes to the outer edges of our own solar system. Traversing the intergalactic void to return to the Milky Way would require energy and technology that borders on magic to us right now. Humanity would basically be forced to accept that we are stranded, and our search for answers about exactly how we got here would become the primary driver of all future scientific endeavor. So, how would humanity's progression unfold? Likely in a few distinct eras. We'd endure days, maybe months, of global shock, slowly coming to terms with our displacement. This would naturally be followed by years and decades of stabilizing our society and mapping out our new surroundings to make fresh discoveries. Eventually, over centuries, this unprecedented event would act as the ultimate catalyst. It would push our descendants to develop technologies we can't even fathom right now, to master our new domain, and hey, perhaps eventually crack the code of intergalactic transit.
So the crucial point is, what does this all mean for science? Well, everything. Literally everything. It means entirely new opportunities for research, wholly unconstrained by our old maps. It means fundamentally changing our understanding of the universe, proving that there are mechanics out there, like, the ability to move a solar system across the void that we never thought were possible. It basically guarantees discoveries beyond our wildest imagination, completely redefining humanity's place in the cosmic order.
Sure, moving Earth to another galaxy would bring some enormous, honestly terrifying challenges. But it also presents an incredible opportunity. Humanity would see the universe in a completely new way. We'd be forced to grow, to adapt, and to look outward with completely fresh eyes, untethered from the familiar history of the Milky Way.
And I want to leave you guys with this final kind of provocative question. Let's say thousands of years from now, our descendants finally unlocked the technology to travel between galaxies after mapping strange new stars, witnessing unimaginable cosmic wonders, and building a completely new history. Would we even want to go back to the Milky Way? Or would this new, uncharted galaxy truly have become our home? It's a really fascinating thought to chew on. Thanks so much for joining me for today's Explainer. I hope this journey through such a mind-blowing concept was as exciting for you as it was for me. Keep looking up, wherever up might happen to be.